Physics 2212, Lab 3, Magnetic Field of a Bar Magnet, by me. The purpose of the lab was to measure the distance dependence of the magnetic field of a small magnet using a magnetometer on your phone. And then to compare results to predicted distance dependence determined by the Biot-Savart law for on and off-axis magnetic fields. Some of the equations we use. Experimentally, we use B, the absolute value of the magnetic field of a bar magnet, is equal to a constant K times R raised to the N, and R is our distance away, and N is what the proportionality, and K is some constant like the magnetic field, or mu naught over 4 pi, kind of a thing. And then a computational model, or this Biot-Savart model, is right here. Mu naught over 4 pi times 1 over r cubed times 3 mu vector dotted with r hat vector in the r hat direction minus mu naught vector. So the procedures were first to determine the magnetic north of your magnetometer, and arrange your phone to magnetic north. So once that is set, either the x or y, value was as close to 0. You set that as your magnetic north, and you found the location of the magnetometer by placing the magnet along the x-axis to determine where the largest magnetic field was. So it would be right here. And then you did it on the y to determine this to be the location of it. And then you moved your phone varying distances away, or the magnet varying distances away, to see how the magnetic field deteriorated or became smaller, and at what lengths those were. So here's some of the data that we got from it. So we got the magnetic field, the average magnetic field at this average distance. And so we use coordination of both these two mathematical equations to then analyze it to equal into this graph. We got that n, r raised to the n, was negative 7.4, whereas it was expected to be 1 over r to the 3, and 147% error. We think that this came from errors in maybe the magnetometer used in the lab, or human error while measuring this. Then some of our off-axis measurements right here. And the way we set up that lab was we made an isosceles right triangle to calculate. So right here, and we calculated what the distance from the magnetometer between the magnet, and then the magnetic field in both the x, y, and z axes. And we corrected for the y component by subtracting the Earth's magnetic field in the y, which was this value right here. And we calculated B net to equal 6.72 times 10 to the negative 5 of the magnet. Here are some of the code from GlowScript. So we set our magnitude of the magnetic field, and then up here, equations, how to make the vectors. Here's what it looks like. Here's our magnet. And that's the perp. In conclusion, what if we had oriented your experiment to compensate for the magnetic field from magnetic north, instead laid out the meter stick at intermediate angle with respect to Earth's magnetic field? How would your results have changed? Well, they would have changed by having a component of Earth's magnetic field in the x and the y direction. So they would made the y one's smaller and your x one's larger. You could have compensated this by if you knew the angle and subtracted the Earth's magnetic field from that. What if you were to stick two identical magnets together end to end and run the experiment? How would I expect the result measurements different? The relation to R would have stayed the same because it isn't affected by the magnitude of the magnetic field. However, the magnetic field would have been much stronger, or the magnitude would have been larger.